Derivatives number 5 focuses on derivative graphs. And the two things we're going to focus on, number 1, how to sketch the graph of a derivative. And number 2, and it's probably the more important part, is you will be given the graph of a derivative and you have to answer questions about the original functions, like where's that original function increasing, decreasing, and where it has max and min points. In this warm-up section, I want to go over some important vocabulary that will come into play as we move through this section. So what it means for a function to be positive, negative, increasing, and decreasing. In question number 1, I'm looking for points that are above the x-axis. That's what positive means. So everything that I have highlighted in blue is above the x-axis. And to give an x interval, you just say where that interval begins, what x value, and then where it ends. So this first one, because of this arrow, it actually has no beginning. So it begins at negative infinity is my lowest x, all the way to the negative 3. And the second one is negative 1 to 2. When you write these intervals, it's important to put a parenthesis whenever you do any sort of infinity. And where you have the numerical parts, you could either put a bracket or a parenthesis like I have in this particular case. It wouldn't make a difference. And if you don't like interval notation, you could always write inequalities for these as well. And here is what the equivalent inequalities would look like. In number 2, I am asked for x intervals where my function is negative, and that just means below the x-axis. So I just pull up all the points where this dips below the x-axis, and I have those highlighted in green. This first interval begins at negative 3 all the way to negative 1. And my other interval begins at 2 and keeps going into infinity. And again, as you write these intervals, just put parentheses on the numerical part, and always make sure you have a parenthesis when you have an infinity. And you're just listing the x values, and it's a common mistake to look at this thing pointing down and want to think this should be negative infinity. But just keep in mind these are x intervals, and as I head out to the right, my x's are actually getting bigger and bigger, and that's why this is infinity. Or you can just put inequalities for these. And here are those equivalent inequalities. The next part wants to know where f of x is increasing. And when we say increasing, that just means loosely going up. So as you move from left to right on this graph, you want to find places where the graph is going in an upward direction. And I have that highlighted here in red for you. And this interval of increase goes from an x value of negative 2 until an x value of 1. And question number 4, my decreasing intervals. This graph has a downward look on these yellow intervals. So from an x value of negative infinity until negative 2. And then we start another decrease at an x value of 1 to infinity. So now let's see how the derivative plays into this. So we know that f is increasing. So I had said f is increasing on this red portion right here. And any time you do any sort of a slope on any portion in here, you will see that that slope is a positive. So f prime, i.e. slope, remember we said that a derivative just means slope. My slope here would be positive. And where f is decreasing, it's all of these yellow intervals. Any tangent line that you draw on this yellow part, it's going to have a negative slope, no matter where you draw it. So my f prime, that is the slope of f, is going to be negative. F is going to have extrema. That's just the catch-all term for maxes and mins. It could be either one. If you look at this graph up here, I have a minimum here at negative 2 and a maximum here at 1. And if I were to do a tangent line at negative 2 or at 1, they would be going horizontally and my slope would be 0. Therefore, f prime is 0 at these points. And if we focus on this maximum point right here, if you look at it, heading into it with the red parts, I have positive slopes, and then I hit a 0 slope, and then I get negative slopes. So on this graph, when my slopes go from positive to negative is where I'm going to have a maximum. And if you look at the minimum, where the slopes go from negative slopes, I hit the 0, and then I go to positive slopes. So I know when these slopes change from a negative value to a positive value, that's where I'm going to have a minimum. And when my slopes go from positive values to negative values, I'm going to have a maximum on that graph. So when I say slope, I really just mean f prime. So on here, I know I'm going to have a max when my f prime goes from a positive to a negative. And when my slopes went from a negative to a positive, that's when I had a minimum. In this next section, we're going to be graphing some derivatives. So you're given the graph of a function, and you have to graph its derivative. So just keep in mind it's all about the slope. On question 5, I can see I have a constant slope right here, and I can just count and see that I go down 3 over 1. So it's got a slope of negative 3. So on that x interval that goes from negative 2 to negative 1, I'm going to do a value of negative 3. And then as I look at the next piece here that goes from an x value of negative 1 to an x value of 0, I see that the slope on this part is I go up 2 over 1, so it's got a slope of 2. So on that interval from negative 1 to 0, I draw a constant value of 2. And then I move to the next piece that goes from 0 to 1. And I can see that this little piece right here, if I count out the slope, I go down 4 over 1. So my slope on this green section is a negative 4. So on that interval from 0 to 1, I'm going to draw a constant value of negative 4. And then one last little piece here to go. From x equals 1 to x equals 2, I have a horizontal piece right here, and I know that slope is 0. So in between an x value of 1 and 2, I'm going to draw a value of 0. So all these little parts that I've highlighted in purple, these little horizontal pieces, that is my derivative graph. And notice all I'm really saying is any point that you pick on the original graph between negative 2 and negative 1, I have a slope value of negative 3. And that's why this is a constant negative 3, because no matter which point you pick on that interval, you're going to get a slope of negative 3. And the same thing between negative 1 and 0. Any point you pick on the original graph, if I ask what its slope is, you're going to say 2. And that's why this has a constant value of 2. And in between 0 and 1, your slope is negative 4 no matter what point you pick. So my derivative graph is at a value of negative 4, and then between 1 and 2 it's 0. Notice when I did the derivative graph, I did open circles where I had these corner points, because we learned in the previous section that the derivative of a corner point does not exist. So that's why my derivative has open circles here to indicate that the derivative does not exist at those points. On question number 6, I've got this cubic function here, and it's got a different slope. There's no place on here that has a constant slope like number 5 had. Any point that I pick, if I draw a tangent line, it's going to have a different slope than any other point. So on a graph like this, I would suggest starting at the max and min points. And what I know is if I do a tangent line at the max or at the min, I'm going to have a slope of 0. What that means to me is my derivative graph will have a 0 at those points. So I'm going to have x-intercepts at negative 2 that relates to this maximum, and another one at 1 that relates to this minimum. Next, I would pay attention to increasing and decreasing intervals. So I would see that f of x is increasing right here. And whenever f is increasing, I know that f prime is positive. And then I know wherever f is decreasing, which is between negative 2 and 1, my f prime is going to be negative. And once I move past 1, f again is back on the increase, which tells me my f prime is going to go back positive. So when I put all that together, what I'm saying is that my derivative graph is going to be positive until I get to this negative 2. It's going to have an x-intercept, and then between these two x-intercepts, it's negative, and somewhere in here it's going to have to turn around to catch this x-intercept. And then once I move to the right of 1, I am back again positive. So the derivative graph is this one that I have in purple, And don't get hung up too much on, how steep do you make this? How low does this dip down? This is just a sketch. The important parts are that I'm above the x-axis up until I get to the -2, because that relates to this increased portion. I'm below the x-axis between -2 and 1, because that correlates to this decreasing. And that at x equals 1, because f again increases, my f prime needs to be above the x-axis. So just pay attention to the zeros and the intervals of increase and decrease, and just place your derivative above and below the x-axis accordingly. And one more thing I want you to pay attention to is my original graph appeared to be some sort of a cubic function. So I don't know exactly what it was, but it might have been, something y equals whatever, x cubed. And if I do a derivative of a cubic, what I'm going to get is something, but then I'm going to have a second power. And that's consistent with what I drew in my derivative, which appears to be a parabola. We have a few more examples on the back. So this next part is just matching. So you have 4 functions, f, g, h, and p. You just have to match up the derivative. So maybe pause and see if you can do it, and pay attention to things like the maxes and mins and how they're going to show up on that derivative graph. Pay attention to intervals of increase and decrease, and that is another thing that will help you out. So when I look at this first graph of f of x, I see my derivative graph should have a 0 at this point right here where I hit that minimum. And as f decreases, that means my derivative graph should be below the x-axis till I hit that 0. And then since f increases, it'll pop above the x-axis when I move past that 0. And the graph that matches up with that is the second one, because I can see that this graph is below the x-axis till I get to that 0, and then I go above the x-axis. And another thing to look for is this is a quadratic, which means it is something squared, like y equals x squared, and the derivative of a second power is a first power, which is a linear graph. On the graph of g of x, what I see first is this graph is always increasing. Looks like it might hit a little 0 here, but if this graph is always increasing, what that means about its derivative is it will always be above the x-axis. So f prime is always positive. And as I look at my choices, I can see that's true of this first graph. It is strictly above the x-axis. It hits that 0, which correlates to this place where that slope of the tangent line hits a 0. On the graph of h, the first thing I would notice is I have a bunch of maxes and mins, and each one of those on a derivative graph is going to be a 0. So I'm going to have zeros at all of those points. And the next thing to pay attention to are those intervals of increase and decrease. So where this graph is decreasing, I'm going to draw the derivative below the x-axis. Where this graph is increasing, I'm going to draw the derivative above the x-axis. And then when this thing is again on the decrease here, I'm going to draw below the x-axis. And then I hit another interval of increase, so I go above the x-axis. And I can see pretty much what I just drew was this graph over here, so that one matches up with h prime, which means p of x has no choice but to be this one over here. But just some features of p of x and how it shows up on the derivative. I'd pay attention to these min and max points, and you can see they relate to the zeros on the graph. Wherever p of x decreases, which is here and here, I can see that this is below the x-axis on those intervals. And wherever my p of x is increasing, which is here and here, those relate to positive intervals on the derivative. And then our last section here has us looking at an f prime graph. So I'm given the graph of the derivative, and I'm asked questions about f. Notice all of these are asking about a graph that I'm not looking at. I'm looking at a derivative graph. So what I know is that f is increasing when f prime is positive. So that's my because, that's my reason. So now I just need to look at the graph and find out where that's happening. And this is my f prime graph, and it is positive on all of these intervals above the x-axis. So that would be from an x value of -4 to 0, and then again from 2 to infinity. And f is going to be decreasing where f prime is negative, and that just means below the x-axis. And I have 2 of those intervals. So from x value of -infinity to -4 is one of them, and then from 0 to 2 is the second one. And I've given you a variety of ways to say that. So you could say f prime is positive. I just wrote a plus. I wrote the symbol. If you want to write out the word positive, that's fine. Or you can use an inequality to say it. So on the second one, I said because f prime is less than 0. You could say f prime is negative. So it's just a personal choice, however you want to say it. But make sure on these, and I put this as my AP exam tip over here, make sure that you refer to the graph by name. So we want to be saying f prime. So f prime needs to be a part of your explanation. You cannot just generically reference the graph or it. Say specifically what it you're referring to. So always refer to that graph by name. The next question wants where f has a maximum. And I know that f has a maximum where my f prime graph goes from a positive value to a negative value. So as I trace along this, I'm at negative values right here. And then as soon as I cross over that -4, I'm into positive values. So right here, because my f prime went from a negative to a positive, what that means is my f went from decreasing to increasing. And if you think about that, what that looks like, if I go from a decrease to an increase, that point where I transitioned is a minimum. So on the graph of f, I'm going to have a minimum at -4. So -4 goes into a minimum category. And as I continue tracing along this graph, I hit a 0 here at 0. And at 0, my f prime values go from positive to negative. What that tells me is that my is going to go from increasing to decreasing. And whenever you have a graph that goes from an increase to a decrease, you have hit a maximum. So f is going to have a maximum at 0. So a 0 goes in the maximum answer. And as I continue on, now my f graph is decreasing because f prime is negative. And then at 2, I go from a negative to a positive. So what that means, it's the same thing that happened at the -4. If f prime goes from negative to positive, that means f is going from decrease to increase. So it looks like this, a decrease to an increase. And that is what generates a minimum. So here at 2, I'm going to have a minimum. So any place where f prime equals 0, which are these 3 green points, I'm going to have either a max or a min. If I switch from a negative to a positive as I move from left to right, that's going to be a minimum. That's why these 2 are minimums. And when I go from a positive to a negative, that one is a maximum. And my reasons look like this. So whenever f prime equals 0, that just leads me into it's a max or a min of some sort, or could be. And the direction that it changes sign tells me which one it is. So when I go from a negative to a positive, as I did at -4 and 2, that is my minimum. And when I go from a positive to a negative, that is my maximum.